Right, hi everyone, welcome to this National 5 video for the percentages topic, which is looking at repeated percentage changes. Okay, first we're going to look at just at 4 examples, but before that, let's see what we're going to learn. There are 3 things we want to be able to do from this video. We want to be able to calculate a percentage increase and decrease using a single decimal multiplier, which may be a slightly different method from what you've used before, but is definitely the most efficient. Calculate a repeated percentage change and then recognise and understand the terms appreciation and depreciation in relation to that. Okay, so the first example is just going to be looking at some revision questions. So a coat usually costs £120 and the sale it has a 35% discount. How much was the coat in the sale? Now before this course for National 5, you may have found 10%, multiplied it by 3, also halved it and then added them all together and then took that on 120 to get your answer. Now within that method there's going to be at least 3 different sums you do, okay, but there's definitely a more efficient method we want to kind of get used to in terms of using or answering these percentage questions. Okay, now the first one is if in the sale it has a 35% discount, you're not really looking for 35%. What you're looking for is the 100% subtract 35%. Okay, so what we're really after is 65%. Okay, now the best way to calculate percentage, definitely in my eyes anyway, is to convert that into a decimal. Okay, now we know to convert percentage into the decimal divide by 100, so 65%, that really means 0.65. Okay, now after you've got good at this, you won't need to write this bit down, but you should be very quickly be able to turn a 35% discount into 0.65. So to calculate this answer is really 120 multiplied by 0.65. Nice and easy, using the decimal multiplier, and that gives you the answer, £78. And the big advantage for this is if you can get used to it, it makes every question after really easy. Being able to do in one line of work in, dead simple. Okay, so example 2, this is where we start talking about National 5 level percentage work. Okay, so Peter puts £3,000 into a bank account which offers 5% interest. If Peter does not remove any money, how much will be in the account after 4 years? Now the reason this is a National 5 question is because after every year your total changes. Okay, to calculate this a long way you have before, you need to find 5%, add it on, get a total, find 5% of that new total, add it on, get a total, find 5% 4 times. And even for 4 years, that's going to be a lot of work. Okay, but what we want to do is if it's 5% interest per annum, okay, that means that you're going to start with your 100% and then you're going to add on an additional 5% of interest. So really what you're looking for is 105%, which is 1.05. Okay, so really what you're going to do is 3,000 times 1.05. That will give you a total. You get your answer, and then you need to do it again, and you need to do it again, and you need to do it again. So we could calculate that total. I don't really care what's in it after 1 year though, so I'm just going to keep that as is. Okay, and then I'm going to times that by 1.05. I'm going to get a total. That gives me the second year, and then 1.05 again, and then 1.05 again. But in reality, I don't really need to do that. Okay, because if I know if I'm timing something by itself 4 times, that's really, okay, I don't need any of this nonsense. Okay, what we really need is a power 4. So it's 3,000 times 1.05 to the power 4. You go to your calculator, you type it in, and it gives you 3646.51875. Now we know we're talking about money, so we don't want all this. It's not giving us any significant figures or anything to do it to, so we're just going to do it to 2 decimal places because that's what we do with money. So 3646.52. Okay, next one. Very similar idea. Definitely pause the video here, try this yourself. Okay, and once you start it, I'll run through it again. Okay, so now you've done that. If you want to put 540 into a bank account, it offers an interest rate of 3.6% per annum and leaves our money untouched for 6 years. How much will be in the account? Okay, so firstly, again, I'll write this down, but you'll very quickly get to the point where you don't need to. 100 add a 3.6 will give you 103.6%. Okay, which as a decimal is 1.036 divided by 100, moving all the digits down to place values. Okay, now the biggest mistake here is to miss out that zero. Okay, but you know if there's a zero up here, there needs to be a zero here. Okay, now what we're starting with is £540. We need to multiply it by our decimal, and then we're doing that for 6 years. Okay, so rather than having 6 different calculations to make, we can just do to the power 6, type in your calculator. Okay, you get the answer 667.6552 and so on, which we want not specified, so it's 2 decimal places because of my 667.66, and that's your answer. Okay, the last bit we're going to look at is actually repeated change, 2 examples. The last bit is looking at appreciation and depreciation. Okay, now these things are very similar, in fact it's almost identical. It's just a different way of phrasing it. Now, appreciation is when something goes up in value. Depreciation is when something goes down in value. So here we've got Penny buying a house for £85,000. In the first year it appreciates by 8%, but in the second year it depreciates by 6%. What is the house worth after 2 years? Okay, so we've got a repeated percentage change again. It's not dealing with compound interest, which is interest compounding over a number of years. It's dealing with 2 changes in subsequent years. Okay, so we are starting with 85,000. In that first year, it appreciates by 8%. So that's 100% with an additional 8%. Okay, which is 108%. Okay, which we know as a decimal is 1.08. So to get that first year, I'm going to multiply 85,000 by 1.08. In the second year, though, it is depreciating by 6%. So we're going to have 100% subtract 6%, which is 94%, which as a decimal is 0.94. So for that second year, we're then going to multiply it by 0.94. Notice how we can't do the powers now because the numbers are different. So we do 85,000 times by 1.08 and immediately followed by 0.94, which gives us, I'll just put it down here, 86,292. Okay, and that's you. Now that's repeated percentage change. Again, go into your class, get some more practice. I'm sure everything will be fine. Go in and get some practice. Ask your teachers if you need any help, or Edmodo, Twitter, anything that you need to ask. Okay, thank you very much.